Good morning, or whatever it is, wherever you are. Alright, so I'm trying to remember where we left this off. I think I wanted to see how if we... what did I do here? Is this difference in Jason brace styles? So you're there. Yeah, okay. I wanted to see how this compared... Well, actually, one thing I noticed in checking that I was in the right branch is that I really would like all of this stuff cleared out. Ooh, okay, there's already a bunch of stuff here. Alright, back up. Star.exe. Oh, I guess he's ignoring. Yeah, at the start.exe you'll get it. Wasn't there actually stuff in build windows? That's mapping. I think this was me. That's built. That might have been me. Maybe the append stuff is all there. Wait, it thinks the entire directory isn't there. Build windows. Now I don't want to say no to icon anything anywhere. And settings are hairy. I can probably exclude patches-star. Well, that's at least more manageable. Reverb cache. And then it's like particular settings than my particular little note file. It tends to be how it does directories, which I guess is fine. So files, directories. Okay, git add dot get ignore all right, scene tiles. So I wanted some kind of benchmark on this, and now see my other tile generation's done. Do I even have a thing? Map, you're working. You're basically where it is, but where's my code pointing right now? You are expecting to run there for the cache. And then output to output tile lists, which yeah, I still have to fix this so that it puts it out to a different directory, because I actually ran my main drive out of space doing this before, so that's a separate problem we'll have to address at some point. Assuming I break down the detail level, but that might just be a software rendering instead of prefab tile thing. Well, actually, for testing purposes, this is fine. If we're going to do 27 and chunk numbers, it's mapping. That stuff moved over there. Output tile list doesn't even exist here. And I think my program is still using that stuff. Data lists. Okay, so that will be completely independent data. So if I was using, I've had date stuff set up at times. But right now, you are pointing at, we're just using one particular file. So all this is conditioned on a path. Path equals, and this is going to be relative, so it's a bit easier. And then we want to set your zoom to do exactly the same thing as this was doing. Assigned but unused. Is do end not a thing? Expecting keyword end. What? I mean, maybe the next is confusing it? Okay, that I can see. Wait, where the heck is... Did I get this at the wrong level? Does do end not work how I think it works? I thought you could just make a block. Well, fine. Okay, so that was the wrong one. Why does that not work? Yeah, you are mismatched. Oh, actually, this needs to be a... So your path... Maybe path is within that. I thought we could just do blocks. And then dir... I think is going to be to here. Oh, except I had this stuff out because it's only for level 29. Okay, now it's complete path. Huh. I'd swear you could just do a do end if you needed a block. So we actually have to remove end and what were you actually matching up with? Oh, we didn't see that before. File equals, oh, because there used to be a block there protecting it. What is this? This is log file. This is list file. Signed but unused. All right, so maybe... $33. Oh, cash plus stir. Okay, so it was not that. Okay, now I need an actual time. Can we just do time? I think that might actually be faster. Of course, maybe could that be the Ming environment? Did I have timing in you yet? I thought I had some. Now, it might be that the database is trying to write to the disk every single time. In which case we'd have to hack up LinearDB. But I was actually wondering if I could use the database, but maybe it has to be a separate database. Then isn't going to have to hack up a LinearDB to be like a memory-only version that does some of the same caching, but doesn't do any disk operations. Now, one thing I can do to help it a little bit is I think, oh, we finished server 5, level 24. On to server 6. As I think I looked at it a bit, and you could actually set value size to 0. I'd want to put a couple of checks in LinearDB to skip the key in that case. But yeah, if Ruby is faster than C, it has to be the file ops. We should probably try the other shell to make sure that that's a comparable, and to make sure it's not an environment thing. This is actually slow enough to be annoying. Maybe we need to back off a zoom level. So where is... like, technically they're competing with each other here, so... Now this would actually be touching the same database file. Wow, this is slower than I remember being yesterday. It was like 1 minute, maybe? And it actually does perform a lot better on Linux. So maybe it's the Ming GW file abstraction and Ruby has a little bit better interface there. I don't remember taking that long. Well, it's long enough that it's not useful. Alright, rm tiles.db and time. Okay. Note to self, do not run long-running programs in the Ming shell. So we actually do have to bump this back out. And we actually did have, that was like 16. Yeah, we had a 16 for that one. U had not actually been changed yet, so I forgot to do that. But now, unfortunately, we have a two-step process. Actually, what did I change in U? Wouldn't change zoom. Oh, I just did make. It's make scene tiles. Okay. It's curious that it didn't write anything out in that environment. Okay, so 16 to 2.6. I don't know exactly how much faster that is, but it's faster. So it would be, one order of magnitude would be 1.6. 2 would be 0.16. So it's not quite 2 orders of magnitude faster. Now, if I did want to use tilesdb, is that because we're timing it? Wait. Really? Oh, you eat the input when you do time. Whoa. No such file or directory. So now it's just outright crashing? But it actually took time, it took some time the first pass through. Hey, Lizzie. Or Timmy, as the case may be. Okay, so you're having the same problem. So that's running. So why can server and company run? I did some Lua for Stepmania, because that's their environment. But I mostly only work on that one in the winter when I'm hacking on stuff. I've got some in ITG songs. I don't, and I guess ITG is kind of derived from Stepmania. Charts from. Oh, okay. $80. Now, this is no longer giving me useful error messages. Now, I guess. We've had problems. Nope, it's not that. So it actually only runs in here. So how are we able to make how are we able to make other programs that run? Well, I guess I don't actually know what this thing runs. Now the problem here is no, actually we normally launch these from the shell. So I've got some version of mapping here. No, I don't. Yeah, that's Shetty. It's Java, but it works. Alright, so I've got our mapping copy. I might have to get some setting files back here for this to work. As long as I'm at the appropriate zoom level, I shouldn't have to worry about the screen. Map pull, you are still set to small. Zoom, not terrible. I think I had to add okay, output directory is local, which is fine for a test. Tile list. It's a small one, okay. So, why do you work fine? Oh, that might actually be an error. Well, okay, so it doesn't completely work fine, but... Maybe it has something to do with these small console programs that are not built as robustly. It's mapping. Yeah, so what the heck is going on? Fortunately, I get no information when it crashes. Uh... But running this in this environment is kind of no good. Because its file operations are really slow. What the heck was it? Make kiss to... Oh, it's not a shell. Oh, I'd have to... Well, it's sort of run. Sort of ran. I don't really care about you. I care about... So this method of building does not make exes that can run outside the Ming environment. And the Ming environment is god-awful slow. So I would have to do something more like the server build and not like the kiss test build. Well, I could go back and do this in some kind of virtual environment. You'd have the virtualization layer. So the regular makefile for this does tons and tons of stuff that we don't need. I think this might actually be generated by the configure stuff. Oh, and what's so frustrating is that I don't, like, all this stuff. Well, I mean, what does configure do? Platforms SDL. So even for the server, we're going through platforms SDL. You go off make file list, which is a ton of stuff. I mean, the link isn't really the bottleneck here. Link headless. So I know what he does for the editors. He actually just swaps the makefile list, which is really kind of ugly. But might be the easiest thing to do here. Make editor. Move makefile list. I guess that must specify the output file as well. Dash change directory. Yes, it did. Make file list. So edit. Well, yeah, edit. So make file list. Okay, we did end up adding a space to it. App name. Oh. Cute trick. Okay. Now we had to make scene tiles, so we need your local. Don't use any of that currently. We don't need the CPP, we did the H. Do need DB common. Game graphics. I guess the good news is I think I could actually bring in some of the file stuff. So there's probably things I don't need here. Okay, unused variable, unused variable. Scene tiles. Okay, I'm not getting the print output. Maybe I actually need to include some of the log stuff. That's taking quite a while. So I know in the other app you still get the well, no, actually, what was the other console I used? Yeah, I still got local epoch time. Oh. Okay. So what did... Oh, that was 26. Jeez. Well, we got it. We got that. This is still fantastically slower. Slower enough that I think I should be doing tests at a different size here. Although part of this was specifically to test some of the sub-iteration at the higher levels. All right, so what we want to do is we want to do the make. We want to time. I guess that actually captures the output. I guess it's more buffered in the other console. And then I want to look at if there's any difference here. Okay, that's 18, that's 19. What? Okay, I just didn't work, I guess. Yep, bash command not found. One shell take it, the other one won't. Okay, they're actually pretty comparable times. There's nothing about the Ming shell. So it has to be file ops in LinearDB. Well, okay, we're also printing everything to a console. Which is our only output right now. I don't expect that to be a huge difference. Oh, that's mixing tiles. Which actually, for our purposes right now, well, it does make it compatible, which I guess is something. Still 18 seconds. Okay, so the print is actually not a thing here. So we need... So I actually don't need the value. Now, if it is file, then that might make a small difference, but I imagine it's mostly seeking and such. Value... I guess I can keep that or... Oh. Oops. Oh. So those got updated and those didn't. Right, that was just a dummy value, which we shouldn't actually need if it works. Where is... And this is where I actually do need to print stuff out, because it matters if that works. Okay, that did reduce the runtime, because we didn't do anything? Now, is that the only reason we would not have printed those out? It appears to be so what would cause a value size if num written not equal to 1, return -1. Okay, so this is the thing I was talking about, possibly having a special case things for 0. Okay, that's key size if, well, we already got a val32. It's already done the structure lookup. Record size in bytes. Does not match in header file. Num written. And then we're checking for not equal to 1. Now this is using value size directly. Num read. In out value. Oh, actually, I don't have all of them yet. Well, it is a right of the key. Num read again. Okay, now what did we miss? And then copy the error everywhere. And then our database name changed. Okay, that did not work how I was hoping. In DB, it is just DB here. So first of all, as is, it continues working. Okay. Scene tiles. Hmm. So where are we aborting here? Well, how about iterator next? Iterative. Okay. Naming conventions. Header size. We should be able to see. Okay, so 1 kilobyte is probably wrote like maybe a header. Yeah, it's maybe a header. So we are not writing even the key. And without even the file writes, we're still taking 8 seconds. That's kind of amazing. All right, so what are we calling? We are calling db put. That does a get or put. Yeah, okay, so you're failing. Put and ignore data ignore data file. Is that what I want to not do any file operations? Only applies if input is true. Updating the RAM hash and assuming all unique values on collisions. That's the declaration. Anyway. Set fingerprint in bucket, num records. Any fingerprint match as a collision. Read key to make sure it actually matches. Oh, I may have affected... I affect the last stop with that. This might have been batching up some other... Oh, no, because there's a right. Well, only if it wrote. Mm. You are in get or put. What the heck is going on here? Failed seek. Failed to seek. In out value, value size. I mean, we shouldn't be even getting there. This is... Oh, this is iterator next. What? Consider fingerprint bucket. Consider fingerprint bucket. Consider fingerprint bucket. Why can you never... I guess because it picks up the operation again. The very, very last thing I did. Consider fingerprint bucket. Right key failed. We should never get here. Consider fingerprint bucket. Lose my buffer every time. Alright, now where the heck are you going wrong? Consider fingerprint bucket something. Alright, so I need to be operating at a much higher... Well, it's still going to be all the rights. Just going to hit fewer different buckets. Well, I can get rid of the... I can get rid of the zoom arounding at least. Alright, we've gotten as much as we're going to get out of that. Read key failed. And that is at... not empty rack. Is in bucket fingerprints. If it hit set fingerprints for file, pause for insert, we'll go into file, non-file insert. Not an empty record. Bin FP equals 0. Bucket fingerprints. Again, what does an empty rec mean? It's like a deleted, reclaimed record? So we got a fingerprint. The bin we're in fingerprint. Bin FB, in bucket fingerprint I. What the heck is I? In rec index. It thinks it's a hit. Read key to make sure it actually matches. The key read failed. Well, from what we kind of see in the tininess of the output, that seems to suggest that we didn't write the key. It is key size. Non-empty rec because of fingerprint collision. Alright, so I actually want to see this as soon as it fails. What else may have happened? Oh, we had a seek miss, which probably threw everything else off. I'm only putting errors right now. I'm not really tracing everything else that happened. I do only have one of these. This is in consider fingerprint bucket again. That's what it says. So we attempted to put, it was an empty record. We thought we had to seek to the end. These are ints, I assume? Seek missed. It's at 7. What the heck is file pause rec? Linear DP header size. How do you not get at least header size? What? Oh, it's a 64. And then ftello has been mapped to ftello 64. Long int. And same result. Oh, I think this is going to be assigned int. We should actually cast it down. Argument 2 has offset t64t. AKA long O. But file pause rec is a uint 64t. Are you also long? Oh. Okay. Most other platforms. Okay, so we have to Windows specific here. And the other way to do this would just be to cast these down to int, because we know they're going to be small-ish. Okay, 711, that makes more sense. So this is where we need to know what goes into our target position. Printf %d plus %d plus %d equals %d. Your DP3 header size. Now, just to be safe, because it might have been cast up. And I'm always always nervous when you're doing these multiple element things about operator priority. Oh, I forgot to specify the final parameter. Although that looks very weird because I already see an extra 8 in there. Oh, times record size. So 0 times record size. Oh. No, okay, I specified 8 for the key. So actually I did see this wrong. Those are times. Is that what I saw? Seven bytes. So we're not writing our header out. Linear DB 3 magic character plus 2 32-bit ints. Header buffer. Oh, this is, well, it's open, but it's truncation. Expected size not equal to file size. Where do you just write your first header? There did the open. If Seco failed to write header truncation file. Let's get or put. Well, it would have to be an open, right? Doesn't exist. Record size bytes. What are our 32-bit ints? Already contain a header. Write fresh header. Oh, it's a write function. Seek to 0. We have a magic string. Which is actually linear DB2 apparently. And that's 3 bytes. Contrary to the documentation. Okay, so 8 plus 3 actually makes more sense. Magic characters. Characters. Oh, I didn't document any of these. Oh, this is actually writing the size of it. So then your header's off. And shoot, now I got a bunch of printfs. And also some code changes I want. No, it's temp path, not mine. Well, these are all fails. The fails should be fine. It is it's that's an issue, and the put result that's an issue. Okay, so that was better. When it didn't have to do a whole lot of work. What were we comparing last? 25? Well, I mean, that's better. But it looks like to make the body of this performant. Now, I do keep saying put. Now, it's a getter put, which always made me wonder if it's going to be any better. Okay, I'm just in a different spot. To check first. So this would be what does... I mean, db get probably looks a lot... oh, it is getter put. What does a db get for existence look like? Well, let's getter put. It returns the value of that. Your return codes. Completely ignore the data file and don't touch it. Updating the RAM hash only. All unique values on collisions. All right, that's value-based. RAM hash table failed. Result less than 2. Records it didn't match. Keep going. Result is less than 2. Return result. Less than 2. Return result. Failed to seek. Okay, a 1 means not found. Does get have that parameter? Actually, the checker will tell me. But in theory, a get wouldn't have to go to the disk, maybe? That may have been ever so slightly faster. But at 25, we're like 1 second in the Ruby. Yeah, okay, so that's faster. It's not the speed I was expecting from C. How do we activate? False, false, true, false. It's a put ignore data file. Ignore data file, update RAM only. This preserves our fread position. You are only used during open right now. This assumes that each key in the file is unique because we generated the file on a previous run. Are there different buckets in RAM than on the disk? Okay, this is the only place we do it where we're moving from one file to the other. RAM hash table. Oh. So this is really more of a get to load it into memory. Wait. Num read. Record buffer, record size bytes. DB file. So this is putting it into, this is putting it into the appropriate position in memory because we're also in the file. Does linear db3.h does not by default expose that function. Although we know exactly what we have to do to make it happen all the time. Okay, so it's checked a few places. That made it slower? Maybe it got itself into a while loop trying to update something. It's like it's not there. Nope, still not there. Nope, still not there. Nope, still not there. Nope, still not there. Okay, so it's not that. It seems like it would be that. And then also skips the consider fingerprint bucket, which I may still do file operations. Yeah. So this ends up touching the disk too much. So I would need to rip this apart to make just a, well, just the hash table without any file operations and understand stuff well enough to deal with that. Free page manager, add bucket. Deletes old area. Close. Free page manager. New page. Yeah, so I don't think it ever... Well, I guess it could overwrite pages. It could do that in terms of clearing memory. RAM hash table failed. So actually we need to duplicate everything because I think I might actually still want the database. Hash table, hash table. There is no file. That will hopefully flag everything that's trying to do file stuff. You don't need a path. Set max load. Number of elements divided by 8 before table starts to expand. Underlying linear probing and linear hashing algorithms. Inserts become expensive due to linear hashing expansion. Higher load factors make it expansion slower. Have linear probing but waste more space and spread data out for running slower disk operations. Depending on hardware and other factors. Okay. You don't do with files. DB current run length, iterator. Bunch of functions I don't call right now. Max file size. Given max load, given the maximum file size. Well, just a size. Force the file. Oh. Is that the RM I wanted? Well, it's not you. Wait. It's not implemented in this database. He did this by modifying other databases. Wait. Oh, did I open up the wrong linear DB? Linear DB 3 dot. Oh no, I'm in that. Oh, get shrinks. Yeah, I think I opened up the wrong one. That was the original linear DB. Okay, page manager. Linear DB3 hash table overflow buckets. File. Okay, so load factor is still a thing. Don't need the path. Get, put, iterator. Well, I guess if I could find force file, one of the other things, it could be a useful tool. Well, not actually, this is a RAM, so it doesn't matter. And then linear db3.cpp. And here I was hoping to be able to just use this, but it appears to be doing disk operations every time to keep our file backed up, and we need to be doing a lot of fast in-memory operations. Alright, so we do not care about any file operations whatsoever. Okay, so there's the hashing function, which in len uint64 in db file write header. Well, we have no header. This is going to be all our open process, which is no path, max load, no file, record size, record buffer, hash table overflow buckets. Does the file already contain a header? File doesn't even contain the header. Write fresh header. Init page manager, read header. That doesn't matter. Reading in all the stuff. Did I return from the block yet? No. File, 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 file. F close. Populate the hash table. Free page manager, delete. Close the file. I'm not sure I properly close things. Has no member file. You're right, it doesn't. Consider fingerprint bucket. Alright, what do we have to do to just not touch the file? So it looks like this. That flag clearly didn't do it. Ignore data file. So this looks kind of like what we've got. There's file, file, file. Input. I'm not seeing adjustments to our internal algorithms here. Do we only store data in the file? Overflow index, file index, record O in the data file. Current bin number. Num buckets, num pages, page size, area. Do you actually store values? So data is only in the file. But this is a bucket. RamDB records per bucket. Bucket page. 4096. So a bucket page has buckets per page, has records per bucket. The page manager has multiple pages. So that records per bucket looks like parallel arrays of fingerprint to index. So if I only treat this as a set, I don't actually need values. All we care about is, does the record exist? Which really is fingerprints. Record number in the... Oh, so this is actually not necessarily a linear... I might not need you. We'll go end of file. This is considered fingerprint bucket. If it equals 0, it's an empty record. In bucket fingerprints. In DB num records. Finished non-file insert. So why the heck did not ignore data file work before? Uh, 0, 1. 1 is not found. If it hit a fingerprint, rec index, if it hit, treat any fingerprint match as a collision, assume all unique data. Once again, this looks like what we want, and then we ignore everything else here. What is, well, that is the same indentation. But this should be after a return. So this is like all file operations. Rec full, but didn't. It's treated as a hit? I'm a little suspicious of that. We'll go with end of file. This is database stuff again. Or get or put. Need to make a new overflow bucket. There's ignore data file again. Oh, insert into bucket, huh? This is expand table. We're ready for this bucket. Hash table size. Memcopy split probably. Should never happen. Insert into bucket. So where is your file index coming from? Temp bucket. Well, that's the array we're not using. So this shouldn't matter. That's file index again. What? No, this is file. Okay. Iterator next. DB record index. fseek. Out key. Oh, because we have file, because we have all of those in the database. The iterator is based on the raw data file. So I need a different way to do that. And I do currently have an iterator. Actually, do I even have keys? Because I've got buckets. Do I even have key values anywhere? Fingerprint mini hash. So I'll get the hash, and we'll have a file index of a record. So I almost do need something that's like a data file to have a log of things we've inserted. Or rather, if it's not currently in the list, then it goes on some giant list. Actually, if all I have is an existence check, so you have no iterator, because you don't store values. Bucket iterator we might need. Iterator init, iterator next. So what we do is we go through, we see if we get a hit. If not, then we're just going to print for now. And eventually that will be the write to the log. So my make file right now, make file list. It's going to be there. And linear. Yep, and that's all on my buffer. Okay. Oh boy, we got some cleanup here. Oh, and there is no iterator stuff. We do instead of here, instead of well, we do have to put it. Then we do value to int. Int pair to key. Oh, was I round tripping this to see? Well, I'm scanning x1, so that wouldn't be terrible. But really what we're doing here is all right, now what are you complaining about? Because you have no file. We probably lost our printer. Okay. The tile DB should just not exist anymore. All right, so some of this time is just going to be printing. And this feels like it's not working because we're doing just too many prints. So we probably want a little crazy value on here. I mean, we often do something around a byte. All right, we should not have a tiles DB anymore. Oh, I forgot the plus plus. All right, I see 61, 62, 63, 360, 388, 360, 387. 358, 389. I guess the way we have to check for merges here is we have to go to a much trivial case. -10 is being printed multiple times, which means it is not working. You know what I really want here? I think what I really want is a Bloom filter. Element is a member of a set. False positive matches are possible. Possibly in set or definitely not in set. Well, definitely not in set is the one we're primarily interested in here. Good night? Yeah. Good night, Lizzie. Empty Bloom filter is a bit array. There must also be k different hash functions into one of the M array positions. Proportional to the number of elements to be added. Intended false positive rate of the filter. Let's see, so I was running out of RAM generating my tile list. And that, well, this might be more tractable in Ruby because it would use less RAM. If you were, well, I might have to do incremental file output of the results. But for comparison, Redis. Hypersonic aircrafts. For Unices. Event Machine Daemon. think that might have been what I saw. For unices, which, I mean, we could go do some virtual machine stuff. Very old. Doesn't even exist. Also very old. Is there a drop-in bloom filter? How to write one? Problem link page. It's a library. How much of a library? Is this like HPP? Example. Include. Okay, so it's a just as an include file type thing. Bloom parameters, projected element count. Now, do you mean elements in the filter or elements in the entire set? One in 10,000. Optional random seed. If not parameters, what does that even mean? Filter.insert. Okay, it does, well, it has an insert for single numbers. We need a 2-element version because this suggests there is an XYZ. Or is that the hash functions? Oh no, X, Y, and Z are the individual values you're inserting. So we'd still have to have some sort of hash of our 2 values. So like double hashing things. Lots of operator stuff. Insert string with length. Plain old data type. Well, 64-bit is a plain old data type. Oh, or we can do data length. So I could probably even do this like int to key type thing. Okay. Because this is the kind of level we need. I could probably get this thing figured out, but this is more what we're trying to do in terms of not duplicating ourselves. Whether it'll be more or less performant, we don't know yet. Downloads. Put this here for now. And actually, there's not going to be a whole lot of database stuff in here. Oh. Oh. It is so silly about doing that as the file with the original extension. All right, so using it, that's the file. We really only have a tiny number of database operations here. Coordinate translation. The DB open actually doesn't really hurt us at all, I don't think. Params dot one thing that's not clear from this, more information, is this the number of elements we expect to call insert on, or the number of elements we well, I guess no, that's collision rate. So projected number of elements is, well, well, the number of tiles is going to be smaller. And it's also going to vary with zoom. So it is about that many right now. It's going to be twice that for births and deaths, but a bunch of them are going to be on the same tiles. Actually, we have some information about this. So right now I've got this. Actually, I've got this directory up right. So right now, it's going to be very, very small for the first several. So 18 files at 8. 59 files at 11. So what was that, like 6 is 18 and 11 is 59. Yeah, we haven't finished typing yet. And he's going to go up rapidly. 719 at 18. And at 23, it's a bunch. So that you could say would be times 3. That's more than times 3. That's way more than times 3. Maybe it is something to do if we calculate the area of a tile, we'd have a sense of how much it would take in. And then 23 is 159,000. Ish. Now, if we did, let's see, 6 bits, uh, 4 bits is 16. That's 120, no, it's 256 is 8, so alternately 128, 64. 11 bits, that's the median number. So 256 at 8. 512 at 9. 1024 at 10. 2048. And then this is almost 24 bits, which should be a well-known number-ish. So it's something like it's the total. We have a number of points that get distributed over an area. And it's like a small subset of the area. But it seems like it might be proportional to the number of lives divided by the area of one tile. So at 6, M60, it's 4096, and we have, well, it actually ends up being a very small number. It still divides it by more. And we have, like 10 million. So that's 2,000, but that's kind of low end. Now, 2 to 23 is that. No, I need to be looking at the width of a tile, not at the... So 2 to the 23 would actually be tile size. We've got a tile width, which is going to be 32 minus 23. So 2 to the 9th. It's only 512. So 19,000 is nowhere near, well, it's off by 1 order of magnitude. Oh, but that was... I did not do area. No, that would only make it smaller. Well, we've also got our around expansion here, which is 500 units. That's, you know, the tiles, yeah, I'll generate more tiles. But the per tile. So we need something that gets, well, I mean, that does get smaller as you go up. And then at the other end, so 2 to the 26. Well, that would be less than 1 each. Which actually, it is technically significant less for the ones that fall into a tile. We're using a very, very small area of it. So number of points. The compression tiles is going to be influenced by the area of the tile. But that's like way more. We said you were like 512? Yeah, that's not nearly enough. Oh, even without doing area. Well, no, 'cause that's going the wrong direction. If we did... Or is it? Because as we go down, the tile width gets smaller, so the number gets larger. What can we... How can we estimate the number we're going to end up using? Of course, it also depends on the area we're covering. Oh yeah, that's why divide by area doesn't make as much sense. Well, actually, let's look at these ratios. So there's that, and $62. So the ratio we're looking for is around 62. We said that that was 2 to the 9 is 512. 256, 128, 64. And 500, but let's see, that was 26. It's still off by a lot. But I guess the upper end is the one that needs to be a little bit better. So that's tile width. So prospective population divided by tile width divided by 8. This is actually a little easier to read. Projected element count. So I guess we could scan through things, get an exact count of the lies. Let's think about the points. Equals, as of this writing, divided by, how do we do tile width here? And that basically makes it a constant, but this is more how we're thinking about it. Or we could have just done 8 here. False positive, this is entirely fudgery. So we'll just take you. Seed is optional. What are you complaining about? Okay, that was a leftover. Params.compute optimal parameters. Bloom filter. And then we need to do place these. If filter dot if not contains so I was just doing this into straight up key, and it was a key width of 8. I think it's all just overrides. Filter.insert. And print the one we inserted. We inserted nothing. So right now we're at a very, very high zoom. It's possible we get a false positive. Which is if you get a false positive on your only element. Then we wouldn't generate that tile. Oh no, this might be backwards. Element is a member of a set. False positive matches are possible. Possibly in set. Or no, definitely not in set. Amount of source data correcting a particularly large amount of memory if conventional error-free hashing techniques were applied. Hyphenation algorithm. So this still needs a fallback to a more expensive method of determining if it's there. False positive probability. So this is, it might be there, so we need to do the disk check. We need to do some sort of real check. But it could tell you if it definitely was not there, we need to insert it, but it won't. But it could return a false positive for a key. That we've never inserted before and make it look like we don't need. Well, that would make it part of the set if we had some way to iterate. Which, of course, we don't. It's just a hash table. Yeah, unfortunately, we don't have the expensive way to determine if it's in the set. This is for a very, very sparse, to avoid checks in very, very sparse areas. So if we were doing the side of things, we're like, well, do we have this tile? We could maybe avoid making the web request on the viewer side. But it's not going to help us generating the tiles we're missing. So I need to go back to my, is my other hashing algorithm going to be the same thing? If you have a hash collision, it would appear that the thing had already existed. Which I guess technically applied to the previous use of linear DB because we're always storing 1. To avoid value collisions, well, no, it's saying hash goes to this index. I guess I didn't really read up if it contained multiple entries at that file position, or how that was marked in terms of how many things you might have there. So for the problem I'm trying to solve, I need to be storing my actual key value to be able to actually determine if the thing is in the set or not. So the Bloom filter just doesn't do that. The RamDB we're working on did not do that. It relied on the file to store the keys and values, and then it could iterate over those. So one way to do it would be to go back to the version that had the file operations. Well, the thing is, files, you can sort of count on the operating system to deal with growing it as big as it needs to be. Memory, you have to be very careful not to exceed your buffers. Or you allocate a positively vast quantity of memory up front, and you just have to kind of reset and expand the buffer if it ends up proves to be wrong. Well, I guess there's always the double and copy style methods. But now we're into writing a pretty significant amount of code to do all of that memory management. So I have to have some sort of structure that holds the actual key values. All right, well, the bloom was an experiment, and I kind of got backwards what it did. And I don't see any easy... Well, is there? Count distinct problem. Cardinality estimators. Approximation of the cardinality. Add on the set, count to obtain the cardinality, merge. All that does is count. I need something that is like the opposite of a bloom filter. It can tell me if something is definitely present or might not be present. Yeah, filter storage. I mean, I guess I could just have a big old list we have to search. Extensions and application, cache filtering. Huh. Avoiding false positives. Finite universe. Non-adaptive combinatorial group testing. Hash to a bit array to determine fastest calculate functions. Amount of counting filters. Delete operation. Bloomier filters. Associative array. Key is not in the map. Map will never return a wrong value for a key that is in the map. spatial bloom filters. But it's still backwards. Is there something that is like the opposite of a bloom filter? Lossy hash table. Only give false negatives. LRU. Millions of tests. There can be some repetitions. Unsafe side for me. Use false positives. There's one such thing. Direct mapped cache. Order of millions could simply use a bit array. Bit set. Probabilistic set with no false positives. With duplicates, processing items we've seen before. Big hash table, start replacing elements. Can check positions that have already been searched. Gloom filter. $1,000 elements. False negatives. Just try to cache. Partial items. Round to the next largest power of 2. There's no explanation of the algorithm. No false positives. ID that was in the slice at the given index after putting the new ID atomically. New filter. Right. New index, old ID, bytes.equal. Oh, So it stores the value, but then swaps the value out at the bucket every time you query it. So it can still do the comparisons. As long as you don't have collisions. Hash map. Hash collisions are not avoided. It's the same index, return false. Match negations, their definitions. Cache with object expiration. And there's bloom filter. Oh wait, this is the CPU direct mapped cache. I'm not entirely sure. Linear DB3. There was something here about collisions. Consider fingerprint bucket. In key, in out value. Two records didn't match. Without finding a place to put value. Need to make a new, okay. So it might just go in an entirely different bucket at a new index? But what if you, so the thing with collisions, okay, cool, you can collide, you can go to a different thing. Well, that would only be for the hash. So if it's comparing the key and the value stored there, we only care about the key. But just the key and doing the file operations associated with that is too much for us. So we have to be able to store complete key values somewhere in order to skip the duplicates, which means we actually have to go back and get some. You almost want to step all the way back to linear DB3. And then we might even have an iterator because we'd have values that are stored somewhere. You have to keep track of indexes, but the index is within a buffer instead of within a file. All right, linear DB. Well, we can get to iteration later. Logging them is probably fine. So really the CPP is going to have all the code. We still need a file. But But we're going to need an extraordinarily large buffer. And I don't yet know just how big that has to be. Now, our buckets right now have had space for offsets. If we cheat and assume our key size, I don't think that's going to be available when we make them necessarily. Page area size. Page area size. Num pages. Num starting buckets. Yeah, so that is the bucket page stuff. I guess file. So you're going to be all upset about, RamDB. Record offs. So this was a file index, not a direct recording of the data. And that's AUINT32. For what we're doing, we'd have to go to a 64. Well, I guess the most straightforward thing. I'm just wondering if I should build the buffer into here. Well, no, because it's supposed to be an index in the entire file. The most straightforward translation is to keep it as index into a buffer. A truly gigantic buffer. Which, where is that? Did that take you out of a header as well? Variable or field? Declared void. Oh. Yeah, so this is going to take and assume that our file pointer is currently at 0. This is all in memory, so we really don't need a header. We don't need a file. Maybe we need to allocate something. Okay, now we're still in open. Does the file array contain a header? So this is doing stuff with the existing file. File doesn't even contain a header. Write fresh header. This is all reading and updating. And reads and writes shouldn't matter. And close, there's just no file. All right, now we kind of have to start translating things to something. So we still have our database. Oh, did I not just comment that out? So linear DB. Yep. Linear DB 3.h. is right below value size. I don't actually need that, doesn't really get in the way. Now, in terms of size, we might have to have some way to specify that. For now, proof of concept purposes, well, that would be where we did our file here. Do I have any idea how many lines are in that one file? Well, we know how many points are in everything. Ooh. Can you even allocate that much? And that's only an approximation. It's probably less than that because of different servers and stuff. Buffer. Value size. Is this not in value size? Actually, it's in key size. And now we're back to the file errors. All right, consider fingerprint bucket. Oh, RamDB header size is 0. Easy way to do that. If read. Well, this is just going to be, say, well, it's an in-out value, so we actually are copying here. I almost want to... I could write little functions that just do buffer ops. It'd still be function call overhead, we wouldn't be touching the disk. And the way we're passing stuff, you have to be there. I guess that actually need to be signature compatible. Which, where the heck is stanlib? Because otherwise I'm going to be writing little copy loops at every read and write. So we've got like something like that, a int count and a so when this is going to rely on fseek style to set the position. That's where it gets a little bit annoying. Maybe we actually, because he doesn't even use count. But that's easier to mess up. If I just swap it out. So we can get rid of all the fseek stuff. Oh, and he swapped these out with 64-bit versions. So this should really be, well, I guess. It's like off 64T. Unfortunately, there was some stuff there that had to swap things out in a Windows-specific functions. I mean, in theory, these all have to be the same for it to work. So we want to go to, and we know he always uses count 1. Oh, actually, this resolves to a mem copy, so I don't need to do a loop. I guess that could still make it a little bit better. All right, so ftel, never seek unless we have to. So this is trying to file pause rec. So this would become a mem copy, and I don't remember my argument order on this. Destination source total size. It looks to me like they're trying to go into InDB record buffer from InDB buffer. Oh, NDDB buffer plus file pause rec. Or NDB key size. Destination, but this doesn't give us any, well, I guess it doesn't fail. Read and write shouldn't matter. Key compare in key. Used in arithmetic. Oh, did I do buffer is void? Where's file pause rec? It was a uint64t. RAM. Oh, I did. memcopy. ftel is totally not a concern, but it's file pause rec again. Num written, I presume we're just checking here. Okay, well, we'll get back to you later. Num written. Memcopy 2 is a write. Oh, he's probably assuming file pause rec gets changed every time we do this, or the file position gets changed. I guess C kind of could have a little local pointer. F right. Already seeked. After reading, according to fopen docs, if empty rec, well, this is just going to be, yeah, so this we shouldn't need. We're only using this as a set. If value size So it's calculating a file pause, but still saying go to end of file. And this is entirely for that. And then memcopy into indb buffer. From InKey into key size. Although, I guess since I'm not really reusing LinearDB anymore, the argument for using the existing code is gone a bit down. We're not using value right now. Memkey. Iterator, we might be able to do. I don't want to deal with it right now. Well, this is. I can only imagine this not going well. Ew. Actual error. Magic string. Sure. Kind, scene, tiles. Haven't used in a while. RamDB open. Collect 2. That might be what throwing it off. Okay, at small size, it goes very fast and gets us one thing. At the zoom we were last doing, I could see that just doing a single entry. Okay. So I guess the proof, well, we pretty much only have inspection, but I know it printed out a lot more with all the things. The real proof would be to get the iterator working. Although this, I guess the streaming method should work. So we had been testing on 77, I think. Yeah, I was getting killed by file ops. Even the prints aren't really hurting it. Oh, I'll get a very small. Scroll back here. So now I have to arrange to have an output file. Well, and I have to, I probably need to have some, I need to define my size and actually check for running off the end of it. I'm actually impressed you could allocate all that memory, really. Okay. And then I guess scene. The thing that was really bothering me before. Well, of course, the fact that I'm printing them probably isn't helping. Yeah. We might be able to see this complete in in a time here. Where was I outputting you to? Output tile lists. That might hit real data. No, I had to move them all as they were, so that's fine. So for one, well, it's just one recent day, which isn't as bad. And this was doing an iteration per file before, so we're going to get no feedback while sub-iterating. So yeah, it takes a bit. So possibly we could have written something a little bit cleaner if we were doing just set exists stuff, but I guess hashing and buckets are going to be kind of useful things in terms of allocating things. Oh, I wonder if this is, you know, in the computer science classes, they're always talking about like red-black trees and tries and things that you never seem to use. This might be where that kind of thing would be useful, because you'd have a proportional lookup time for thing and set. Actually, I mean, we've got something that kind of works now. Stand set. Does this environment even have stand? Logarithmic complexity. Implement those red-black trees. Well, there might be a lot of memory allocation in there, is the problem I have with that. Especially with the stand thing. Alright, so we have max load for open calls. Net page manager. File offset. RAM buckets per page. Convenience. Defined here. Records per bucket. Okay, so it's defining these with the structures that have the appropriate field. Define so actually that was partially dependent on the key size we put in. Number of inserted records causes table to expand incrementally. I guess this would really be kind of like max records. Oh, you don't need a semicolon. Now, so I could store that value in the record. Oh, this is really a placeholder to remember whether we're doing that. But in theory, anywhere we are writing, okay, that's, oh, so it's not the only mem copies. Okay. Into record buffer, from buffer, into buffer. If, well, it's really file pause rec. I kind of just want to have a value. Wait a minute, what's max int? Okay, we're fine. Well, we're going to multiply that by a small number. So actually that is max records. But we were checking size. So actually, can you just do that by index? File index I. Rec index. Because I mean, if rec index is greater than max records, then you're just done. Mem copy. Well, it's going to be wherever file rec pause. File pause rec gets calculated. Was that? Where were you? Okay, that's consider fingerprint bucket. Is that a different consider fingerprint bucket? No. That's for the value key size. Key size. If it's a hit. Because I would write the key twice. And copy into buffer based on this bucket index. What's bucket index? Get or put. Where do we... There we are. File index 0. NDB num records. New bucket. File index 0 greater than or equal to the next records. You cannot write that. That should be all of those. And are we still behaving? Okay. So now I need scene tiles. Okay, so we fopen input. We fopen output, which we are currently in server, so we'll eventually have to get this pointed at somewhere useful. This could be a setup for eventually making this a variable. Probably need to generalize that a fair bit. Output fill. So that should become fprintf. What is... See, if that's that, then that should be, you'd expect that to be that. We were using spaces here. And yeah, there is a database. Oh, man. Okay, that's not unexpected. All right, so the next thing we need for this is to figure out how we would do directory iteration and perhaps file arguments for input and output directories as command line arguments, since we've got our own main, we're not really using the minor gem stuff. Oh, I guess I do have a server name here kind of faked up. That would probably go into the output file. And then that might actually be fast enough to get work done in a reasonable time. Admittedly, these are not the worst of times. The worst of times. Family trees would be server 1. Well, that would really be the worst of times. Oops. But if we're scanning through all of these files incrementally, that would be the worst of times. Well, I don't know if this is the most expansive, but it's the most input records, so that's probably around it. What's the modifier we have to use? Control, Shift, copy as path. Yep. I must have overwrote that when I'm messing with it. Okay, got you. And this whole system is expecting you. Failed. Oop, one too many dots. I mean, I haven't really looked at the data yet, or like really looked at it to say it's right. It could be getting completely bogus presence tests. Let's look at tilelist, tilelist. And, well, that's significantly larger. And if we look at this, right, because the look around effect is actually expanding the number of tiles. And I guess no, we did earlier do where it was a very, very small set of tiles. We only saw the one. Yeah, so the look around is actually hurting me more than the tile compression is helping me. But hopefully when we get this iterating directories, we will still get some compression. Actually, this is a pretty large look around. So from 34,000 to 175. It's only like 6 times. We're doing a lot more extra tiles than that. So there's still some condensation there. All right. Well, I have gone kind of late again. Getting caught up in stuff. Credits. Thanks everybody for watching. And everybody who hosted me. So we've got game engine, game, Twitch integrated. This is about when I tend to be on. I guess I've been going a little bit late lately. Yeah. Well, how about making the hero? It's been a little while. And I suppose you might be doing some pathing stuff. So everything was way cool to hang out. Making of a Hero is working on an RTS MOBA and kind of doing all the code behind the scenes for that. Thanks for hanging out with me. Goodbye until next time.